Hi, this is Alfawzia Nihar from At Home Tuitions. Welcome to our session today. In today's video, let us learn how to solve system of equations graphically. Graph a system of linear equations on a coordinate plane and identify its solution. A system of equations is a set of equations with the same variable. If the equations are all linear, then you have a system of linear equations. To solve a system of equations, you need to figure out the variable values that solve all the equations involved. Here, let us discuss how to find it graphically. System of linear equations is just a set of two or more linear equations. In two variables x and y, the graph of a system of two equations is a pair of lines in the plane. First, let me explain you the three possibilities. After graphing, you will get only three possibilities. The lines intersect at 0 points. It means the two lines will never meet. And the second case is the lines intersect at exactly 1 point. This is the answer we get in most of the cases. Both the graphs will meet exactly at 1 point. And the third possibility is the lines intersect at infinitely many points. It means the two equations represents the same line. If this is one line of a graph, then the other equation would be exactly on the same line. It means the two lines intersect infinitely at many points. Hope you are clear with the three possibilities. Solving graphically is applicable only when you need a rough answer. If you want the accurate exact answer, you should use either substitution or elimination. Only if you are doing it in using your calculator or computer, you will get the very accurate point while doing graphically. Or you just get approximate answer. Let me take one example. We have two equations. Please note that these two equations are on the slope-intercept form. Slope-intercept form is nothing but equations of this type. Hope you see the general format. Okay, these equations are of the same type. Y is isolated on one side of the equation and we just have a x term and a variable and a constant. By looking at the first equation, you can say that in the place of m we have 0.5 and in the place of b we have 2. It means that it has a slope of 0.5 and y-intercept of 2. So using these two information, you can draw the line for the equation number 1. Same way, for the second equation, you can say that in the place of m you have negative 2. So it means slope is negative 2. In the place of b you have negative 3. It means that y-intercept is negative 3. Using this information, let me graph it. This is the graph, the two lines for these equations. Now let us see at which point these two lines intersect. These two intersect at negative 2, 1. So x is equal to negative 2 and y equal to 1. This is the solution for this problem. Sometimes graphing a single linear equation is all it takes to solve a mathematical problem. Other times one line just doesn't do it and a second equation is needed to model the situation. This is often the case when a problem involves two variables. Solving these kinds of problems requires working with a system of equations, which is a set of two or more equations containing the same unknown variable. Okay, let me show you the system of equations and what the graphs of individual equations within the system reveal about the mathematical relationship of a variable. First one is, if the graphs of the equations intersect, then there is only one solution. That is true for both the equations. It means we have just one solution. If the graphs of the equation do not intersect, for example if they are parallel, then there are no solutions that are true for both the equations. So we say that this case has no solutions. If the graphs of the equations are the same, then there is an infinite number of solutions that are true for both the equations. So this is the case where the infinite number of solutions occur. Hope you are clear with this concept. The next example shows how to find the common point, the point where the two lines intersect if you are given a linear system in the standard form. Okay, this is an example. Let us place these linear equations in slope-intercept form. That is, we are going to isolate y on one side of the equation and shift all the other terms to the other side of the equation. Subtract 2x from both these sides. Divide both these sides by negative 3. Negative over negative is positive. This is the equivalent equation for the equation number 1. This is of the form y equal to mx plus b, where b is 0 here. So the slope is 2 over 3 and y-intercept is 0. Now let's rewrite the equation number 2 in the same way and write it in the slope-intercept form. Adding 4x on both the sides and dividing the entire equation by 2, we will get, divide the entire equation by 2. This is the equivalent equation for equation number 2. Slope is 2 and intercept is -4. Using the slopes and intercept, graph the lines and use the graph to find the common point. That is, you have to check at which point the two lines intersect or meet each other. Here is the graph for line 1 and line 2. Now these two lines intersect at the point 3 on x-axis and 2 on y-axis. So the intersection, point of intersection is 3, 2. So whatever method you are following, it may be substitution, elimination or graphical method, you just have to check your answer by presenting it as an ordered pair in the given equation. You should get both the LHS and right hand side of the equation same. Let me check in both the equations. Replace x by 3 and y by 2 and check whether the LHS is equal to RHS. The equation holds true. Now let's do the same thing for equation number 1. Equation number 2. Replace x by 3 and y by 2. Equation holds true for this too. So the solution we got is the accurate answer. Hope you're clear with this example. Let me show you an example where you get no solutions. That is when you get two lines that are parallel. Let us discuss one example step by step. Here is your example. Let me name the equations as 1 and 2. Place these lines in slope-intercept form. That is, we are going to shift all the other terms to one side of the equation and isolate y on the left hand side of the equation. Add 2x on both the sides and divide the entire equation by 5. So we will get, this is the equivalent equation for equation number 1, where the slope is 2 over 5 and the intercept is -15. Let me rewrite equation number 2 in the slope-intercept form and identify what's its slope and intercept. Isolating y on left hand side, we'll get, this is the equivalent equation for equation number 2. Here the slope is 2 over 5 and the intercept is 1. Let's graph these two lines on a graph sheet. They both have same slope and these two are parallel lines. So the answer is no solution because these two lines does not intersect at all. Hope this makes sense to you so far. I'd like to give you one more example where there are infinite solutions. Both the lines are one and the same. Here is an example. You can do in the same way. Rewrite the equations in slope-intercept form. Equation 1 would become, equation 2 would become, I'm just going to shift 6x to the other side by adding 6x on both the sides and dividing the entire equation by 2. So we will get, we have rewritten the given question in the slope-intercept form. Now let's graph it. Even before graphing, you can say that these two equations are very same because the slope and intercepts are same. That's it for this example. Both the lines are the same. Dependent system seems to give beginning algebra students the most trouble. Remember that we are looking for points where the two lines intersect. That is most important. If the lines are the same, when they will cross at infinitely many points. Am I right? Because of this, we have to use special notation to indicate an infinite set. Notice that we have already put the line in the y-intercept form, y equal to mx plus b. So it is not a big leap to write the set final order pair solutions in the form x comma mx plus b because y equal to mx plus b. In some textbooks, you can also see this different notation. I'll write the notation on the board. Both are considered as the correct form. Please consider this example. You can also graph two equations in T-tree method. T-chart we say no. First rewrite the equations in y terms as usual we do in the slope-intercept form. These are the slope-intercept forms. Now assume some values for x. For example, a 0, some positive numbers and some negative numbers. Assume some values for x. Now plug in this x values one by one in the equation and write the y value, its corresponding y value. Let's first start for equation number 1. So when you replace x by -1, you'll be getting -7, x by 0 you'll be getting -6. When you replace x by 1, you'll be getting -5. Same way, when x is equal to 2, y equal to -4 for equation number 1. Same way you can find the values for second equation. Then you can plot the xy pairs on the graph, so your graph will be accurate when compared to the previous slope and intercept method. This will be very handy when the equations are very tough. Hope you're clear with this concept, solving system of equations graphically.